Hello, my name is Ala Hussein from Syria. I will present to you my research about anti-lock braking system. We will start with the introduction. ABS, anti-lock braking system, is a system that helps us to control the vehicle in sudden braking situations. It increases the driver's maneuverability and decreases the distance of braking. It contains an electronic control unit, ECU. This unit increases and decreases the hydraulic pressure of the brake at the wheels to prevent slipping. ABS stops the car in a much safer and more comfortable way. Physical analysis. To analyze the system in a correct physical way, we must study the forces acting on the car and the torques acting on the wheels. And these are the equations. Where Fr is the friction force on the wheel, Fl air resistance force. It is usually neglected in the other studies, but it will be used in the current study for accuracy in calculation. Gr moment of inertia of the wheel, Mr friction torque on the wheel, Mb braking torque, mu coefficient of friction, lambda slip ratio, Fn normal force, C1, C2, C3 and C4 constants related to road roughness, Vf linear velocity of the car, Vr linear velocity of the wheel, D drag coefficient, ρ density of the air, and A cross-sectional area. Mathematical modeling. After the physical analysis, we performed the mathematical modeling in 4 steps. 1. Set values. 2. Building simulating model without ABS. 3. Simulation the control unit. And 4. Building simulating model with ABS. Set values and building simulating model without ABS. We set these initial values. Then we build a model for the mechanical equations represented in the following diagram. Simulation the control unit and building simulating model with ABS. We designed a block diagram to make it easier to simulate the control unit. We used an integral controller to simulate the control unit. This figure represents the integral controller. This controller increases and decreases the output value in each integration process until the output stabilizes on the ideal value. This equation expresses the outputs of the controller. Then we add the integral controller to the previous simulating to get a model for a vehicle with ABS, which is represented in the following diagram. Results. Figure 1 illustrates that the time of braking is reduced when we have anti-lock braking system. With ABS, the time interval is 5.22 seconds. Without ABS, the time interval is 7.77 seconds. Figure 2 shows that with ABS, the slip ratio is limited, whereas in absence of ABS system, it is large and equal to 1 for most of the time during the motion. With ABS, it ranges from 0.11 to 0.145 for most of the time. Figure 3 demonstrates that the speed of the tire and speed of the car go to 0 simultaneously, with a time interval not exceeding 0.05 seconds. Whereas without ABS, the speed of the tire goes to 0, then the speed of the car goes to 0 7.74 seconds later. That means with ABS, the wheel keeps rolling until the moment the car stops. The torque of braking is constantly changing when we have anti-lock braking system, as shown in figure 4. While without ABS, it is constant and equal to 4000 Newton meter. This shows how the controller regulates the value of the torque. Here are the references, and thanks for listening.